Hello everybody. I'm just eating my breakfast, coffee. Now, let's proceed to another topic of chemical engineering in my chemical engineering diary, of course. So there's a lot of topics to be discussed, right? That's why it took 5 years to complete that curriculum, BS Chemical Engineering. Okay, but this time it's gonna be a very interesting topic. Okay, because it talks about motion and movement of matter. Okay, that could either be solid, liquid, or gas, but this is more focusing on the liquid or the fluid. Okay, this is all about uh, transport phenomena. But before discussing the overview and basic concepts of transport phenomena, let me introduce to you my hair. Look at my hair. Oh, right? So I remove all my hair because it will, disturb me during my sweating moment during my metabolic cycle, during my jog exercises. Like I keep on wiping my, here. So to avoid that, it's better to eradicate or remove my hair. Okay, and after 2 weeks, after 3 weeks, it will just appear. Okay, because you know I have a very high keratin protein. That's why I think so. That okay, I don't have problem with the potential of baldness. Okay, because my hair too much fast in growing. Okay, so like that. So transport phenomena. Okay, when we talk about transport phenomena, it deals with the transfer or the transmission of molecules from one point to another. Okay, so when speak about molecules, okay, it is really a molecules of matter. Again, could it be solid, liquid, and gas? But most of the times we are dealing with fluids or liquid here. Okay, so if we talk about transport phenomena, it involves three molecular transport. Okay, or three molecules uh, specific transport. Okay, so we have the momentum transfer or momentum transport. So this is really a transfer or a transport of momentum, okay, in the fluid. So here, in the first momentum transfer, we are focusing in the fluid flow, okay, how the fluid flow to a pipeline, to a certain conduit, like that. And then this is the center and focus of fluid dynamics. Okay, we speak about dynamics. There's a movement, a motion, a study of the motion of the fluids. And of course, if we study the motion of the fluids, we also know the force involved producing that motion. So that is momentum transfer. Okay, but before that, we need to understand what is really a momentum. Okay, in our physics, as we can remember, momentum is really involved velocity, changes in velocity. Okay, from point 1 to point 2, initial velocity, final velocity, like that. It's not really on the speed because we are dealing here with a vector quantity. Okay, when we speak about velocity, there's a vector quantity, so the direction is very necessary. Okay, could it be there, here, there, there? Okay, could it be from higher velocity molecules to lower velocity molecules, like that? Okay, just like dealing with tropical cyclones and typhoons. So the speed is, let's say, kilometer per hour, like that, and then northeast, southeast. Okay, referring to the direction. Okay, north, south, east to west. Okay, but I think here we are not dealing with the kind of direction. We are referring here the kind of direction that is from high velocity molecules to lower velocity molecules, how fast and become slow like that. Just like a chemical reaction, right? But here more on the higher velocity molecules to lower velocity molecules, the change of our direction. Okay, like that. So momentum, okay, mass times the velocity, the mass of the object times the velocity of an object it covers, and it requires change in direction. Okay, don't forget that one. That's why we don't deal with speed. Okay, but the same unit, but and same meter per second like that. But here, more on talking about the flow rate, or shall we say the volumetric flow rate, like that, the mass flow rate. Okay, we talk about rate, that is with respect to, time, right? If there's a rate, there's a time. Okay, something like that. So that is the first momentum transfer. And then if we talk about momentum transfer, we need to understand what is diffusion all about. Okay, diffusion, the diffusion rate, the diffusivity values, like that. Here, our diffusivity value is the momentum diffusivity, or the kinematic viscosity. Okay, that's very important. Okay, it's our constant here in the momentum transfer. Okay, going back to the diffusion, when we speak about diffusion, there is a momentum spread. Okay, momentum spread meaning to say there's mass and velocity of an object between particles. A momentum spread, okay, between particles could either be atoms or molecules of a matter. Okay, like that. And then this diffusion could be attributed by the external pressure and the shear stress. Okay, very clear, huh? Attributed by external pressure and the shear stress. Okay, like that. And now, number two, we have the energy transfer. Now, there's a little bit of confusion here because uh, during our study, we're not really dealing that as an energy transport, but we are referring that as a heat transport, or specifically the heat transfer. But generally, this is an example of an energy transfer. Okay, so an energy transfer. So a heat is an example of an energy. Could it be plus or minus or positive or negative? Heat is a form of energy. If there is a transport or transfer of energy molecules from one point to another in a system, specifically that involves the changes in thermal energy, okay, and okay, applying the quantities of temperature and heat, of course, so that is heat transfer. Okay, that is from higher temperature to lower temperature. There's an energy transfer or energy transport in a system from higher temperature to a lower temperature that involves heat, specifically that is heat transfer. Okay, so here we touch a little bit of the heat transmission. Okay, that is the heat transfer through convection, heat transfer through conduction, and heat transfer to radiation. Okay, such as the electromagnetic waves, electromagnetic radiation, focusing on the radioactivity, right? As you can remember in our chemical reaction kinetics, the alpha ray, the alpha emission, the beta ray, the beta decay, and the gamma rays and the X rays. So radiation is also an energy under heat transport or heat, okay, transfer. But here I think we are dealing more on the heat transfer through conduction. Okay, from one substance heat transfer from one substances to another substances in a solid particle. Okay, I think we also touch a little bit of convection, the heat transfer from one fluid medium to another, something like that. Fluid and liquid. Our media, sorry, our medium is fluid and or liquid in convection, and our medium in conduction are solid substances. Okay, there's a difference. Okay, like that. So the third will be and then by the way, usually we will using the thermodynamics also, the principles of thermodynamics in the heat transport or heat transfer. So we should not also forget the formula of heat is equals to mcpdt here. Okay, MCPDT with the mass of an object. Object here we're referring to a medium, could either be a gas or a liquid, something like that, okay? The specific heat of a fluid or liquid like that, and the delta change in temperature. So MCPDT, you should not forget that one, okay? And of course, we should not forget also the formula of the heat flux. Okay, that's equal to the rate of heat transfer over the area. Again, there's a rate, so delta change in, there's a temperature. Delta change in temperature with respect to time, because that's a rate, right? Something like that. Okay, that is heat transfer or heat transport. And now the third one will be the mass transfer or the mass transport. So in here, there's an energy, no, a transfer or transport of um, molecules, okay, particularly from higher concentration to lower concentration. So this is the difference, right? Talking about the concentration, okay? For the heat transfer, talking about the temperatures, changes in temperatures, okay, or the heat involved in the system that's being transferred, okay, or the energy itself, because heat is an example of energy. And then momentum transfer, we need to transfer, of course, the momentum, okay, that is in the fluid dynamics and the motion movement of a fluid. Here in the mass transfer, we are focusing more on the molecules or the substances from higher concentration to lower concentration. Okay, here is very important to know the diffusion coefficient of materials, or what we call as the mass diffusivity. Okay, in these three transport phenomena, we have important values of the different diffusivities. Okay, in the mass transfer, we have the mass diffusivity or the coefficient of diffusion or diffusion coefficient of material. Okay, and then heat transfer, we have the thermal diffusivity, because thermal is about heat. Thermal diffusivity. Okay, of course, if there is a thermal diffusivity, sorry, we need to account also the thermal conductivity, okay, of any fluids or any substances or any liquid, something like that. And then for the momentum transfer, we need to determine the uh, momentum diffusivity, of course, from the word itself. We forget from the word itself, just add diffusivity. But here, the momentum diffusivity is called also the kinematic viscosity. Okay, something like that. Okay, so in here also, it's very important also to note the driving force. Transport. Okay, phenomenon. Okay, phenomenon and transport phenomenon, because it's three, right? Okay, so that's very clear already. Okay, now before touching with the problem solving, we need to employ the different laws also here. So as I told you, after scientific research done by our scientists, there will be a scientific law, and this law is driven by different equations. Later we will be touching some equations, specific equations for three, but I need to specify the law, what is needed here, okay? In the momentum transfer, we need to use the Newton's law of viscosity, okay? Remember that one, Newton's law of viscosity. Maybe it will come out to the examination, asking you what law is applied in the momentum transfer or momentum transport. Your answer will be Newton's law of viscosity. As we can remember, we have three laws of motion in physics. Okay, the law of inertia, the law of acceleration, and the third law of motion, which is the law of interaction. Right? So that also be related here in the Newton's law of viscosity. Okay, but here we are more focused on the fluid flow and fluid dynamics. Okay, so it's very enjoyable topic. Okay, the movement and the motion of the fluids. We study and the force behind it to produce that kind of motion. Okay, Newton's law of viscosity ha for the momentum transfer. Okay, for the heat transfer, we have to use the Fourier's law of conduction. See, conduction is involved, so not the convection, the radiation. Okay, but I think that would be also applicable the convection and radiation, but I think we're focusing more on the conduction. That's why we use the Fourier's law of conduction. And the third will be the mass transfer. We need to use the Fick's law, Fick. Okay, Fick's first law of diffusion. That's why I told you we need to understand really what is diffusion all about. That's why we talk about diffusivity, blah blah blah, so on. So in a transport phenomena, there is really a transfer, a transport of molecules and its direction. Okay, something like that. Could it be from the top to the bottom, like that, from the left to the right, or point A to point B, something like that. Okay, so that's gonna be our transport phenomena. Okay, any questions so far for this interesting topic? Okay, by the way, the most uh, basic example of transport phenomena is that when you make your coffee, I have here my coffee. Okay, okay, like that. Then if you boil the water, okay, that starts with momentum transfer. Okay, because if you boil that one, it starts to develop from uh, higher velocity to lower velocity, something like that. The velocity of the molecules changing. Okay, the mass of the object and the velocity changing. Okay, like that. Our object here is water. Okay, or a fluid or a liquid, and then there's a velocity involved when you heat that one. So there's a changes in the velocity. So momentum is there. Mass of the water, then the velocity of the water, final and initial velocity, something like that. And then, secondly, there's a transfer of heat from higher temperature to lower temperature. At first, it's not very hot, and then when you heat that in the kettle, the water, it will become hot. So there's a transfer of the, the temperature, okay, or transport of temperature. And then the third will be the mass transfer. And then when you pour this water into the coffee and into the sugar, then there's a transfer of the molecules. Okay, meaning to say the concentration involves there, the changes in the concentration. Okay, as you pour and mix the coffee mate, the coffee, and the three substances, the water, the hot water, the coffee mate, the coffee, and the sugar. Four. When you mix that one, there's a transfer of the concentration between each other. So that is mass transfer. So in that simple making of a coffee, the transport phenomena has been involved. Okay, from boiling the water like that, and then going down to the mixing principle of coffee, the sugar, and the hot water. Okay, and there's a lot of transport phenomena, of course, in our environment that we ourselves haven't recognized and noticed it a lot. Okay, so we don't have to specify that. If we have to study that gradually, then we can understand that our world is governed also by transport phenomena. Okay, like if there's a movement, there's kinetic energy and a lot of energies, for example, chemical energy, electrical energy, okay, mechanical energy, thermal energy, radiation energy, gravitational energy, hydraulic energy, pneumatic energies, those kind, or electrical energies, those kinds of energy, or the light energy, those kind of energies are under with a molecular energy transfer or transport under heat transfer, something like that, or heat transport. Okay, this is very clear. It's very, very important to study the transport phenomena And I don't think so. It has been studied with other courses. I think so. It's also studied in mechanical engineering, the thermodynamics and the flow and flow, right? Same as chemical engineering. Okay, but I don't think so with other, other engineering courses. I'm not sure. Okay. Thank you so much for watching for this overview of transport phenomena, the momentum transfer, the heat transfer, and the mass transfer. Thank you so much. If you like this video, then you can click the notification bell of I Am a Singer, Eternal Voice, and then if you are not subscribing at my channel, then you can subscribe also much better, and you can leave a comment, of course, in the comment section. You can even like also. Thank you so much for watching this live stream, short live stream of mine. God bless everybody. Bye bye.